This is the General Purpose Workstation, or GPWS, which is essentially a form of laboratory hood that was used to contain particulate matter and any toxic chemicals that might be inadvertently released while working with the rats during the hematology and dissection experiments. And you can see here that I'm deploying a variety of little boxes that contain the numerous pieces of equipment that were required for those hematology and dissection experiments. The folks at Ames Research Center spent an awful lot of time putting together these kits, and we sure appreciated it. We used Velcro and double sticky tape to retain a number of the small items, and you can well imagine that trying to perform laboratory experiments in zero-G would require a different mechanism of restraint and organization than on the ground. Here Ray is removing a cage from the research animal holding facility into this essentially a cloth sock, which is part of the general purpose transfer unit that's used to transfer that cage across the cabin volume and to the GPWS. And in this way, the rodents were kept isolated from the cabin air volume so that fecal matter or feed particulates could not be released. This is a good opportunity to see what the cage looks like. It's essentially a long drawer. You can see there are two screened panels, each one representing a separate cage for an individual rat. And you can see that it's quite a nice little mechanism for containing both the animals and the feed and the feces trays and the automatic watering system that plugged into the animal holding facility. On this particular day, we were performing some hematologic experiments in exactly the same way that they were performed on us as human subjects. Catheters were inserted into the rat's tail veins, blood samples were collected, isotopic tracers were injected into the rats, and blood samples were again collected in order to determine iron kinetics and red blood cell production rates in the rats in just the same way that were performed on us, the humans. We had a very unique opportunity in performing the dissection experiments on the rodents, in that we were able to collect bone marrow and spleen and thymus, which are the blood-forming organs, in order to study the progenitor cells for those blood cells in their organ of origin. In addition to a variety of other tissues which were sent around the world to a number of research scientists. Here I'm making a pneumethylene blue stained blood film, and this particular stain is for immature red blood cells in the circulation, which then gave us a complete picture of the release of those red blood cells from the blood-forming organs and their development into mature erythrocytes. Ray is working with some microhematocrit centrifuge tubes from which we determined packed cell volume, and as well kept those blood samples for later analysis for iron-binding proteins in the blood. While Ray and I performed some of the hematology activities, Shannon and Dave did most of those, and Ray and I did most of the dissection work, and so we had 4 people working in that hood quite a bit, and you can see that we're all different sizes, and I'm very happy to report from a human factors standpoint that the GPWS functioned very well. We were very happy with the placement of the arm ports. We had foot loops customized to our specifications, and as you look at it, it looks pretty much like it does on the ground when we're working in it. You can see how comfortable we were spending a number of hours working in this particular facility.
The next sequence of scenes will show many of the flight deck and mid-deck activities we performed. Here John is flying an in-flight simulation of the landing task. It's a refresher type trainer that we evaluated, flew it for the first time on this flight. It will continue to undergo evaluation over the next several flights to help the crew, particularly in these longer duration missions, in performing the landing task and staying current. Both John and I flew this, and then John and Bill and I performed the entire flight activities from all the way around the hack and down to landing as a crew to work crew coordination. Here I'm just working with the autopilot to perform an orbital test we did. It's an orbital acceleration research experiment, basically an attempt to characterize the on-orbit drag that's on the vehicle. And that's what the vehicle is doing during that test roll about the plus x-axis of the vehicle, part of the calibration for the accelerometers. Earth observations on this flight, we had a real bonanza because of great weather and great viewing opportunities, a long mission, and a good orbital inclination. This is a wide-angle view of the southwest United States with the Grand Canyon in the foreground, progressing up towards the Mojave Desert, and you can see the San Andreas Fault and Los Angeles on the other side of it and the entire Southern California coast. Just about 3 minutes later on a pass such as this over the United States, you might change lenses and do some work with the cameras, then you're ready to take another gorgeous shot of the front range of the Colorado Rockies. Colorado Springs is on the left. Denver will be coming into view shortly here on the right. There it is. And then on the left, that snow-covered peak is Pikes Peak. And then a few minutes after that to New York City. This is a view centered on Manhattan Island with Central Park in the center. We have some New Yorkers here, I can tell. This Earth OBS imagery is used by geologists, meteorologists, ecologists, and a number of Earth and planetary scientists use this for scientific data. This is just a microbial air sampler device, which also coincidentally illustrates some interesting principles of physics here. It has a fan in it that turns, and from the torque effect, it starts the entire device turning in 0G, and then as I tap it, it starts to precess gyroscopically. John is performing some force push-offs here with a force gauge, and with the suite of very sensitive accelerometers we have on the vehicle, we're able to determine some structural dynamics and doing some studies for future microgravity research flights. They can measure accelerations on the order of a millionth of a G.
As has been mentioned, this is the longest shuttle flight ever, and for that reason, John impressed upon us the importance of housekeeping. Here you see Rick taking a vacuum cleaner, and well, we don't have any carpet to clean, but he did use it to clean off the filters to keep our electronics working. We had to work hard to contain all our garbage, and here you see John compacting garbage and then putting it down underneath the floor of the middeck, and we had 2 compartments under the middeck where we stowed all our wet trash. We also had a lot of opportunities to participate in the Shuttle amateur radio experiment. And using the Shuttle amateur radio experiment, we contacted 19 secondary schools around the world. One school in France had their conversations relayed throughout that country, and over 10,000 students either listened or participated in the experiment. In addition, we contacted thousands of amateur operators throughout the world, and we think we really got the word out about how exciting science can be. We also felt it was important to take care of ourselves physically. Here you see John riding a stationary bicycle, and as you can see, he found it very relaxing, as did we all. We also had a series of experiments under the Extended Duration Orbiter Medical Project to see how well prepared we are at the end of 14 days. Here Rick was doing glucometry to measure the glucose level, which Rick, Ray, and I did over 4 separate days. Rick was the operator, and I was a subject on another extended duration orbiter experiment, and this was the lower body negative pressure device. And here you can see me in the bag and Rick making sure that I'm staying healthy and comfortable and keeping the experiment progressing. The concept here is to draw a negative pressure on your lower body to pull bodily fluids back from your head and upper body into the legs, so that your body thinks from a cardiovascular standpoint that it's back on the ground. I was in the bag for 5 hours on the day before landing, taking salt tablets and drinking water, trying to force fluids into my body, and we think it's a very effective countermeasure preparing us to come back. John, Shannon, and I also participated in an experiment, which you can see John connecting here, which measured our blood pressure and heart rate throughout the entry and landing phases.
After 2 weeks in orbit with a microgravity research laboratory, we reconverted the laboratory back to a spaceship, and here we are on entry day, Mach 17, 200,000 feet. You could see the flames out the front window. We're in the middle of a fireball during re-entry. And Dave took this photography around the flight deck, and so you can get some idea of what we're doing on board during that time frame. Here the vehicle is subsonic now. We're rolled out on final, aimed about a mile short of the runway to do the landing task. What a beautiful flying machine. Back into the cockpit, Dave took this as we're in the flare, and then Rick's putting the gear down here. Bill's calling out the MLS accuracy, and we're going to land the spaceship. And the vehicle touches down here at about 230 miles per hour. As I derotate, Rick puts the drag chute out, and we roll on out. And I'll just tell you the bottom line of this space shuttle mission. It was a tremendous success, and medical researchers We'll learn more about human physiology as a result of all of this data, and therefore will enhance their ability to cure illnesses that plague people here on planet Earth.